In this video, we're going to look at how to compare fractions with unlike denominators. So there are several methods of how we can compare fractions. One method is to change your fractions to decimals. That's useful when you have fractions that are very close in value. It's not always practical if your fractions have large numbers in the numerators or denominators, though. A second method would be to find common denominators and then just compare the numerators. A third method would be to draw pictures. That will only work though when you have fairly small numerators and denominators where you're able to accurately draw pictures. And your last method would be to use benchmark fractions to compare your fractions to, and then to look at any missing parts as far as how far away each fraction is from your benchmark fraction. So in problem number 1, my fractions are 49 over 50 and 13 over 14. I'm not going to change these to decimals because that's going to be a long division problem, and I'm not going to find common denominators because I don't see anything in common with 14 and 50 that's not going to be a very large number. I'm also not going to try to draw pictures because there's no way I'm going to be able to draw a picture accurately split into 50ths or even into 14ths. So what I'm going to do instead is see how far apart each of my fractions are from benchmark fractions. I notice that both of these fractions are very close to 1 whole. My first fraction is actually 1/50th away from 1 whole, and my second fraction is 1/14th away from 1 whole. 1/50th is a very small part. As a matter of fact, it is smaller. It is a smaller part than 1/14th, which means that the part that this fraction right here is missing is a smaller part than what this fraction is missing. So that means that my fraction on my left, 49/50ths, is closer to 1 whole than 13/14ths is. So 49/50ths is greater than 13/14ths, which is answer choice B. In my second example, I'm comparing 11/12 to 22 over 24. And I'm not going to change these to decimals because that would be too time consuming. And I'm also not going to try to draw them as pictures because I'm not going to be able to do that accurately enough. But I do see a common denominator for 12 and 24, and that common denominator is going to be 24. So I'm going to change 11/12 to 24s. I can multiply by 2 over 2. 11 times 2 is 22. So I have the same fraction, so these two fractions are equivalent. My third problem, it says which number sentence is true, and the fractions are 3/5 compared to 9/15. I see again another common denominator between 5 and 15, and that common denominator is 15. So I'm going to change this to 15ths by multiplying by 3 over 3. 3 times 3 is 9. So I have the same numerator again. These two fractions are equivalent. Answer choice C. In my last example, I'm comparing 13 over 24 to 6 over 11. And this is one where I might choose to change both of these fractions to decimals because it does appear that they are both very close to 1/2. And they have fairly small denominators, so it's not going to take me too long to change them to decimals. But before I do that, I'm going to see if I can reason out by comparing them to benchmark fractions. So the first thing I'm going to think about is they're both very close to 1/2. This one here is 1/24th greater than 1/2. And this one is 0.5 elevenths greater than 1/2 because half of 11 is 5.5. So now knowing that both of these fractions are greater than 1/2, I'm simply looking for which of these parts are larger. Whichever part is larger is going to be my bigger fraction. So it's very hard for me to tell at first how big 0.5 over 11 is. So I'm going to try to change 0.5 to 1 whole. So I'm going to multiply that by 2. If I multiply that by 2, I must multiply by my denominator by 2 so that I keep an equivalent fraction. So this gives me 1 over 22. So now what I'm really doing is comparing 1 over 24 to 1 over 22. And 1 over 22 is a larger part, so that means 6/11 is farther from 1/2 than 13 over 24, which means it's greater than 13/24. I can confirm my last answer by changing both of my fractions to decimals. To change fractions to decimals, I'm going to do a division problem, 13 divided by 24. The decimal goes after the 13th because the decimal is always to the right of the ones place, and I can add as many zeros as I want after that decimal. So now I'm just going to divide, bring my decimal up. 24 does not go into 1 or 3 or 13, but it does go into 130 5 times. 5 times 24 is 120. A remainder of 10, so I can bring down my next place value. 24 goes into 100 4 times. And 24 times 4 is 96. Can bring down my next place value. So 24 goes into 41 times. And I could continue my division if I wanted, but I don't know if I need to compare anything after the thousandths place yet, so I'm going to go ahead and do 6/11 as a decimal first. So again, 6/11 is a division problem, 6 divided by 11. I'm going to go all the way to the thousandths place to compare. 11 does not go into 6, but it does go into 65 times. And I can go ahead and regroup. 11 goes into 50 4 times. It doesn't really surprise me that my tenths and my hundredths place are the same, because when I was comparing them in the last step, I noticed that both my fractions were very, very close to each other. So I'm going to have to go all the way to the thousandths place, and 11 goes into 65 times. So I've confirmed that 6/11 is approximately 4 1,000ths larger than 13/14.